In this question, we have a radium-178 atom that undergoes nuclear decay according to the following equation. Our goal is to figure out what's happening and what type of decay is happening. So, looking at our equation, we're starting with radium with 88 as the atomic number and 178 as the mass number. So that means we have a radium atom that has 88 protons, because 88 is our atomic number, the number of protons. And then the mass number is 178, which is the number of protons and neutrons together. So if our mass number is 178, and we subtract the number of protons, which is 88, that will get us the number of neutrons, which is 90. So we've got 88 protons and 90 neutrons to start with in our radium atom. Then on the right hand of our equation, we have Rn, which is radon, which has an atomic number of 86 and a mass number of 174. So an atomic number of 86 means we have 86 protons, and a mass number of 174 means we have 174 protons and neutrons together. If we subtract 86 protons, that gets us 88 neutrons. So we've got 86 protons and 88 neutrons. We've also got this alpha, that's our symbol for an alpha particle, which has an atomic number of 2 and a mass number of 4. If the atomic number is 2, that means we have 2 protons. Our mass number is 4, so 4 protons and neutrons minus 2 protons gets us 2 neutrons. So we've got 2 protons and 2 neutrons in our alpha particle. Now, if we have 2 protons, that means we have a helium atom, because helium has an atomic number 2. So this is labeled as an alpha particle, but it's also known as a helium atom that has 2 protons and 2 neutrons. However, it doesn't have any electrons, so it's actually just a helium nucleus. All right, so let's try and answer our questions now that we've had a look at what's going on. What is emitted when radium decays in this way? The radium turns into radon and emits this alpha particle, which has 2 protons and 2 neutrons. In other words, it's a helium nucleus. So we're emitting a helium nucleus consisting of 2 protons and 2 neutrons. Which of the following best describes what happens in the radium nucleus in this process? So looking here, we started out with 88 protons and we ended up with 86. So we've lost 2 protons there. We started out with 90 neutrons, we ended up with 88 neutrons. So again, we've lost 2 neutrons there. So we've lost 2 protons and we've lost 2 neutrons. So that means B is going to be our correct answer. The nucleus loses 2 protons and 2 neutrons. And what is the name for this process? Well, we're emitting an alpha particle here, so this one is called alpha decay. So in alpha decay, the original atom loses 2 protons and 2 neutrons, which are lost in the form of an alpha particle, also known as a helium nucleus. In this question, we have a fluorine-20 atom. It undergoes nuclear decay according to the following equation. So let's figure out what's going on. We're starting with a fluorine atom that has an atomic number of 9 and a mass number of 20. So we've got our fluorine. The atomic number of 9 means we have 9 protons. Our mass number of 20 means we have 20 protons and neutrons together. If we subtract the atomic number, which is the number of protons, that gets us 11 neutrons. So fluorine's made up of 9 protons and 11 neutrons. The fluorine turns into neon, which has an atomic number 10 and a mass number 20. So we've got neon. Atomic number 10 means we've got 10 protons. We've still got a mass number of 20. So 20 protons and neutrons together minus 10 protons, that gets us 10 neutrons. So we've got 10 protons and 10 neutrons in our neon atom. Then we've got this symbol, which is the beta symbol, with a -1 for the atomic number and a 0 for the mass number. What this represents here is an electron. Normally we have a positive number for our atomic number, which represents the number of protons that have a positive charge. The -1 represents an electron which has a negative charge, and the 0 mass number shows that we have no mass because electrons don't have a mass. So we've got this beta particle, which is just one electron. We also have this other symbol here, this kind of V symbol with a line on top. That is an anti-neutrino. It has no charge and no mass, and it's just another of the particles that's emitted in this case. All right, so that's what we have emitted in this situation. All right, so let's go ahead and answer our questions. What is emitted when the fluorine-20 decayed? Well, we know we've got an electron and an antineutrino emitted. Which of the following best describes what happens in the fluorine nucleus? So we initially had 9 protons. We ended up with 10 protons. So we've gained a proton there. We initially had 11 neutrons. We ended up with 10 neutrons. So we've lost a neutron there. So what actually happens in this situation is one of our neutrons actually turns into a proton. So we had 11 neutrons. One of them gets made into a proton. So we lose a neutron, leaving us with 10. We gain a proton, leaving us with 10. In the process of the neutron turning into the proton, it emits an electron and an antineutrino. So our answer to this question is going to be A. We had a neutron that turned into a proton. That remained in the nucleus. And then an electron and an antineutrino were emitted. So that's going to be answer A for this one. What's the name for this process? Since we're emitting a beta particle or a beta particle, this is called beta decay. We'll do one more question here. This time we have a thallium-206 atom undergoing nuclear decay. Let's again look at what's going on. So to start with, we've got thallium with an atomic number of 81 and a mass number of 206. We've got 81 protons because our atomic number is 81, and we've got 206 minus 81, which is 125 neutrons. Then, afterwards, we still have thallium. It still has an atomic number 81, and it still has a mass number of 206. So it's going to be the exact same atom afterwards, with 81 protons and 125 neutrons. However, notice that at the start we had this star next to our thallium atom. That star represents that it had more energy, or it's in a higher energy state. And then what's emitted is this symbol here, which is the gamma symbol, which has a charge and a mass both of 0. Gamma represents an electromagnetic wave, a gamma wave, which is high frequency. So that's what we have emitted here. So we can see we had a higher energy thallium atom, And the atom itself doesn't change, but it releases energy in the form of this high frequency electromagnetic wave. And that's how it reduces the energy state of the nucleus. So what's emitted? It emits an electromagnetic wave of energy. What best describes what happened inside the nucleus? Well, we know the nucleus didn't change. The number of protons and neutrons was the same, but it rearranged itself somehow into a lower energy state. And that's how it was able to release that energy in the form of the electromagnetic wave. So answer is going to be C here. Our name for this process is gamma decay, because that's a gamma symbol or a gamma wave. So we've got 3 types of decay here: alpha, beta, and gamma. Alpha is a helium nucleus made up of 2 protons and 2 neutrons. In beta decay, a neutron turns into a proton and it releases an electron, which is also known as the beta particle, and an antineutrino, which are both emitted. And then in gamma decay, the number of protons and neutrons in an atom doesn't change, but the nucleus rearranges itself into a lower energy state and releases the energy in the form of a high frequency gamma electromagnetic wave.